Given a 3 times 3 matrix A and 3 times 1 matrix X, then you obtain a matrix B, which is 3 times 1. So in this case, if let's say the A is given, B is given, and you are going to find the X, we can use the Cramer rule. So this is the formula for the Cramer rule. First of all, you need to find the determinant for the system matrix A. So after you find the determinant for the system matrix A, then you can find the x1, x2, x3 directly by substitute the determinant A here. At the upper part here, you need to substitute the right hand side vector into the first column to find x1, into second column to find x2, into third column to find the x3. Let's try with this example. First of all, we can extract the system matrix from the coefficient here. So you can obtain 9 components from A11 until A13, from A11 until A31 and A33 here. Then we let this to be the A matrix. So we have to perform the determinant for A matrix. Be careful with the bracket here. So this is wrong. It should be corrected to this to indicate determinant of the matrix A. And after we perform the determinant, so 0.3 remain, 0.52 remain, 1 remain, and then you have positive, negative, positive, and you take the determinant for the first element, 0.5 minus with 0.3 multiplied 1.9, you obtain this. Continue with the second element, you cross this element, and then take the determinant 0.5 multiplied with 0.5 minus with 0.1 multiplied 1.9, you obtain 0.06. And then for the last element here, cross the third column and you take the determinant for this term, then you should be able to obtain 0.05. Once you compute, you obtain negative 0.0022, so you can substitute it at the denominator for x1, x2, x3 formula. Then take the right hand side vector and substitute inside the first column for the determinant A. Then you should be able to obtain this component for x1. Again, you substitute the right hand side function inside the determinant at the second column here. Then you should be able to obtain this component. Lastly, substitute this to the third column and substitute the determinant here to this, and by computing the determinant and divide with the determinant A here, and you should be able to obtain the answer for x1, x2, x3 respectively. Normally we use the Cramer rule for the equation n less or equal to 3. So in this case, if you have equation more than 3, so we have 4 times 4 matrix here, multiply 4 times 1 vector, then you get the output to be 4 times 1. When you perform the determinant on a 4 times 4 matrix here, you see you cannot use one procedure to solve it. Instead, you need to perform the determinant again inside the equation for all of these components. Same to do with your x1, x2, x3, x4, where you have the determinant to compute similar to this procedure. So this is the limitation for the Cramer rule to solve multiple equations with more than 3 equations. So we say that it will be less efficient to solve the problem by using the Cramer rule. Not only by hand, computing the determinants by using computer is also time consuming. and less efficient compared to other computer methods such as the Gauss elimination method.